Hello children, let's start with a new unit of class 12th and the name of the unit is Electrostatics. The topics which we shall be discussing today are electric charge, Coulomb's law and Coulomb's law in vector form. Children, do you know what is an electric charge? Electric charge is a fundamental quantity that is responsible for all electric phenomena. It is a property of all atomic particles. Now let's study some properties of electric charge. Children, electric charge exists in two forms, positive and negative. Like charges repel and unlike charges attract each other. The smallest amount of free charge that has been discovered is equal to the charge on an electron or a proton. The charges are quantized. Now children, what is the meaning of quantized? Quantization of charge means the total charge on a charged body is an integral multiple of a minimum charge E, that is, charge on an electron. The net charge in the universe does not change, that is, the electric charge is conserved. Charge is invariant, that is, the magnitude of charge does not change with its speed. Charge is a scalar quantity. So children, I hope you have understood the properties of electric charge. Students, let's start with Coulomb's law. The electrical interaction between two charged bodies can be expressed in terms of the forces that exert on each other. It was Charles Augustin de Coulomb who made the first quantitative investigation of the force between electrical charges. Coulomb's law is the fundamental law governing interaction between charges at rest. Now let's start with the statement of Coulomb's law. Students, the force of attraction or repulsion between two point charges at rest is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. The formula for Coulomb's law becomes F equal to K into Q1 Q2 over R square. Now children, here K is a constant of proportionality and Q1 Q2 are the charges, and we can say this force is proportional to the product of the charges and inversely proportional to the square of the distance between them. The value of this constant is 9 into 10 to the power 9 Newton meter square per Coulomb square. The actual value of K is 1 over 4 pi epsilon naught. Here epsilon naught is called permittivity of free space. Its value is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. Children, while stating Coulomb's law, it was assumed that the charges were kept in vacuum or free space. When the charges are kept in a medium like water, mica, paraffined paper, the medium affects the force between the charges. Due to this reason, a quantity known as relative permittivity was being introduced. So children, what is relative permittivity? It is the ratio of the absolute permittivity of a medium to the permittivity of free space. Children, I hope you have understood Coulomb's law. This Coulomb's law is in scalar form. Now let us study the law in vector form. Let Q1 and Q2 be 2 point charges separated by a distance r. Let F21 denote force exerted on Q2 due to Q1. So F21 will be equal to 1 over 4 pi epsilon naught Q1 Q2 over R square into R12 cap. Similarly, F12 will represent force exerted on Q1 due to Q2, and the formula becomes F12 equal to 1 over 4 pi epsilon naught Q1 Q2 over R square into R cap 2 1. Children, the only difference between F12 and F21 value is the difference of R12 and R21. They are oppositely directed. So R12 cap is equal to minus of R21. At the end, the answer comes out to be F21 is equal to minus of F12. This shows that the two forces form an action and reaction pair. Also, F21 and F12 act along the line joining the two charges. Hence, electrostatic force is a central force. Hence, we can say Coulomb's law in vector form can be written as F equal to 1 over 4 pi epsilon naught Q1 Q2 over R square into R cap. Here R cap is a unit vector. I hope you have understood the topics which we have discussed in the video. Thank you, children.